Hello dear aspirants, this is Dr. Sourav sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076, and our email ID is sourav.classes@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay, like various other examinations, ISI, CMI, TIFR, NVHM, etc. So please feel free to contact if you need any help from us. So now we are going to solve a problem which is appeared in the ISI MTech CRS or the cryptography question paper, and the question is telling us that let A be an n cross n matrix with entries Aij equals to plus minus 1 for all 1 less than equals to I, j less than equals to n. Prove that 2 to the power n minus 1 divides the determinant of A. So let us see what can we do with this. So they told us that our AB what? AB a n cross n matrix and the entries of A are plus minus 1. Okay, very good. All right, let's tackle this problem step by step. So we are given an n cross n matrix where our entries are either 1 or minus 1. We need to prove that 2 to the power n minus 1 divides the determinant of it. Okay, very good. So now first we have to understand the problem. So let's recall what the determinant of a matrix represents. The determinant is a scalar value that can be computed from the elements of a square matrix, and it encodes certain properties of the linear transformation described by the matrix. So for an n cross n matrix, the determinant is the sum of products of entries where each product consists of only one entry from each row and each column multiplied by a sign depending on the permutation of the columns. So given that each entry is my plus 1 and minus 1, each product in the determinant's expansion will be plus minus 1. Because we are multiplying n numbers, each of which is plus minus 1. So therefore the determinant is the sum of many terms, each being plus 1 or minus 1. So our goal is to show that the sum is divisible by 2 to the power n. Very good. So now let us understand the initial observations. So the possible values of determinant. So since each term is in the determinant is plus minus 1, the determinant, we can easily say that determinant of A should be equals to some k, and k should be belongs to z. Okay. So now each corresponding to a permutation. Now moreover, since there are n factorial terms in the determinant, each corresponding to a permutation, so the determinant is at least minus n factorial, and at most it could be n factorial. But we can say more. The determinant must be even if our n greater than equals to 2. Since our plus 1 and minus 1 cancel in pairs. Okay. So now divisibility by higher powers of 2. So we need to show that the determinant is divisible by 2 to the power n minus 1, not just by 2. This suggests that the determinant has a lot of evenness built into it due to the structure of the matrix. So now let us explore the small cases. Okay. So let's look at small values of n to see if we can spot a pattern. So let us take for our n equals to 1. Then we what can we get? So then we would get only a. Okay. So then our determinant of this will be what? Will be either plus 1 or minus 1. So we can easily say that our 2 to the power 1 minus 1 is equals to 2 to the power 0, which is equals to 1. So 1 divides any integer, so this statement holds for n equal to 1. Okay. Now consider our n to be 2. Then we get a should be my a, b, c. Okay. Very good. Then our date of a will be ad minus. Now each of a, b, c, d is plus 1 or minus 1. So our ad and bc will also be plus minus 1. So hence we can say that the determinant of a should be lie between only this. And we can say that 2 to the power 2 minus 1, that is equals to 2 to the power 1, which is 2. And 2 divides the all possible cases. So now for n equals to 3, let us take it. The determinant is a sum of 6 terms, each plus minus 1. So possible determinants are even numbers between minus 6 to 6. So they are minus 6, minus 4, minus 2, 0, 2, 4, and 6. So from this we can write 2 to the power 3 minus 1 is equals to 2 to the power 2, so which is 4. We can easily say that plus minus 4 and 0 is divisible by 4. Now plus minus 2 and plus minus 6, are this possible? Let's see if we can get our determinant of a equals to 2. So for example, let us take a matrix. 1, 1, 1, 1, 1, that will be minus 1, then 1, minus 1, 1. Very good. So then let us calculate the determinant of it. So the determinant of it will be 1 into, we should get 1 into 1 minus minus 1 into minus 1. Okay. Minus of it 1 into 1 minus 1 into 1 minus this plus 1 into minus 1 minus 1 comma 1. Then we can 1 into 1. So then we could write that will be 1 into 0 minus 1 into 2 plus 1 into minus 2. So the determinant is my minus 4. We got minus 4, which is divisible by 4. Maybe plus minus 2 is not achievable. So let us take another example. So let us take our a to be 1, 1, 1, 1 minus 1 minus 1, minus 1, 1, minus 1. So the determinant of a will be 1 into minus 1, minus 1, minus of minus 1 into, okay, minus 1 into minus 1. This, and then we could plus 1, then 1 into 1 minus minus 1 into minus 1. So that should be 1 into 1 plus 1 minus 1 minus 1, then we could get this. So finally, we are getting 2 plus 2 plus 0, which is equals to 4. So again, this is divisible by 4. Okay. So it seems that our n equals to 3, the determinant is divisible by 4, supporting our claim. Now, general approach. For the small cases, it seems that the determinant is divisible by 2 to the power n minus 1. To prove this generally, we can use the following strategy. The row operations, that means perform row operations that preserve the determinant's divisibility properties. Induction using mathematical induction on n, and consider and modulo arithmetic. Consider the determinant modulo 2 to the power n minus 1. Okay, let's try induction. Now, for n equals to 1, date of a is equals to plus minus 1, and our 2 to the power 0 is equals to 1 divides any integer. For n equals to 2, as shown, the determinant is divisible by 2. Okay, now the inductive step. Assume that for an n minus 1 cross n minus 1 matrix with entries plus minus 1, the determinant is divisible by 2 to the power n minus 2. So now consider an n cross n matrix A and compute the determinant of A expanding along the first row. So our determinant of A will be summation j equals to 1 to n, that will be minus 1 to the power I plus j a1j, sorry, that will be 1 plus j, because we are doing uh, in the first row. So then the determinant of aij, sorry, that will be a1j. Very good. So where our A1j is the submatrix obtained by the deleting first row and jth column. So each A1j is an n cross n minus 1 cross n minus 1 matrix with plus minus 1 entry. So by the inductive hypothesis, our this thing should be divisible by this. Now therefore our date of A is a sum of n terms is divisible by 2 to the power n minus 2. Hence, our date A is divisible by 2 to the power n minus. Very good. But we need to show it's divisible by 2 to the power n minus 1. That is one more factor of 2. To see this, note that the sum of the entries in any row is even. Since each is plus minus 1 and there are n entries, so sum is, so the final sum will be n into some combinations of plus minus 1. Okay. But more precisely, the sum is even because adding plus minus an even number of terms gives an result, gives an even result. But actually for our n greater than equals to 2, the sum is even because the number of plus 1 and minus 1 can differ by at most n. But more importantly, the sum is congruent to n modulo 2, but this is not directly helpful. Okay. So instead, consider that in expansion that the determinant of aij are not independent. There is a dependency that makes the total sum more divisible. Alternatively, consider that we can perform row operations to simplify the matrix without changing the determinant's divisibility by powers of 2. For instance, we can add the first row to all other rows, since adding rows does not change the determinant. After adding the first row to, say, the second row, The new second row will have the entries. They will be are 0 or plus minus 2. Since our 1 plus 1 is equals to 2 and 1 minus 1 will be 0. Okay. Now expanding the determinant along the second row, the each non-zero entry will be plus minus 2 and the corresponding minors are determinants of n minus 1 cross n minus 1 matrices with entries plus minus 1. Am I right? Yeah. So hence hence this thing will be divisible by 2 to the power n minus 2. Thus each term in expansion is plus minus 2 into something divisible. Let us call it some b, and we know that our 2 to the power n minus 2 divisible by b. Okay. So entire determinant is divisible by what? We can have these 2 here and this 2 to the power n minus 2 here. So then finally we can say that our 2 to the power n minus 1 divides the determinant of A. So we can also give a formal proof by row operations. So this was the sketch of the proof. Okay. So now here's more formal proof using row operations. So start with the matrix A whose entries are plus minus 1. Now add the first row to every other row. The operation does not change the determinant. So the new entries in the rows 2 through n. So each I this thing and plus aij ai1 plus aij, which is 0 or plus minus 2. Now the matrix has the first row with plus minus 1 entries and all other rows have entries divisible by 2. Now expand the determinant along the first row, which is done by this thing. That means the determinant of A is equals to summation j equals to 1 up to n, and that will be summation of this A1j and determinant of A1. Now each A1j is an n minus 1 cross n minus 1 matrix with where the first n minus 2 rows are rows of the original A with one row added to another. So their entries are only 0 and plus minus 2, except possibly the first row, which is plus minus 1. Now by induction, the determinant of A1j is divisible by 2 to the power n minus 2. We know that since it's smaller than it's smaller matrix of the same type after appropriate row operations. Therefore each term this is divisible by 2 to the power n minus 2, and the sum is divisible by 2 to the power n minus 2. Okay. But since all rows except the first in A have entries divisible by 2, so the minors determinant of A1j are actually divisible by higher powers, ensuring that the determinant of A is divisible by 2 to the power n minus 1. A more precise way is to note that after adding the first row to others, all rows except the first have same entries divisible by 2. Then the determinant is divisible by 2 to the power n minus 1 because there are n minus 1 rows with entries divisible by 2. And each time we expand, we pick up a factor of 2 from other rows. So the conclusion will be what? After carefully analyzing the structure of the matrix and using properties of determinants and row operations, we conclude that the determinant of an n cross n matrix with all entries plus minus 1 is divisible by 2 to the power n minus 1. Okay. So we have proved that our uh, 2 to the power n minus 1 can divide the determinant of A, which satisfies the given definition here. Okay. So again, I am telling that if you have any other mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp. Also, rather you can drop an email to our email ID. Then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.